Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dogba Jr., your math tutor and an instructor of mathematics at the University of Liberia. In today's lesson, we want to look at additional problems under the quotient rule. So we said we want to use the quotient rule to find the derivatives of these problems. Remember, we can also use the first principle of derivative to find the derivatives of each of these problems. But if you want to know how we can do that, please watch our previous videos on how we can apply the first principle of derivative. So let's get started. Now, before we solve these problems, I want us to quickly review a powerful tool, the power rule. Now, the power rule says if we have x raised to some n, assuming that I include some ax raised to the power n, where a is the constant and a is not actually equal to 0. So if we have ax raised to the power n, if this is a function, it means that the derivative of this function, which is y prime, or we can say dy by dx. Now we say dy, that is the derivative of the function y with respect to the derivative of the variable of the function x. So to find its derivative, the rule says we must bring down this power, whatever power it is. So we drop the power n, and then we subtract 1 from this power, so it's n minus 1. That's all. So assume that we have y equals to 2. 2 is representing a x raised to the power 3, for example. So we're going to multiply this 3 by this 2. It gives us 6. And we subtract 1 from the power, so it's x raised to the second power. What if it was y equals to 2x to the second power? In the same way, it would have been y prime now, right? It will be y prime. 2 times 2 is 4. We subtract 1 from the power, it gives us x to the first power. What if it was y equals to 2x to the first power? So this now will be y prime. The power here is 1. So it's 2. 1 times 2 is 2. When we subtract 1 from this, we get x raised to the power 0. And any expression raised to the power 0 is just equals to 1. So it's like saying 2 times 1, which is just equals to 2. What if it was y equals to 2x raised to the power 0? Now, 2x raised to the power 0, it implies 2. So whenever you see any constant, it means a variable is attached to it, but that variable is raised to the power 0. So this now will give us y prime to be 0 times 2, which is 0. We say x, we subtract 1 from x, it gives us negative 1. But 0 times any expression is just equal to 0. So that's why we said the derivative of a constant, a derivative of a number, is just equal to 0. Any number. So here's a quick review. Now let's continue. So this is important because throughout we will be using it. Okay, we solved the first problem. Question 1 says f of x is equal to 3x minus 2 all over x squared plus 7. So in previous video, we said if we have a function f of x that has a numerator function f of x, small f of x, divided by a denominator function, small g of x, the derivative will be, that is f prime of x, will be g of x, that is we just rewriting g of x, times the derivative of f of x minus f of x times the derivative of g of x divided by g of x all square. So now, in this problem, our numerator is our f of x and our denominator is our g of x. If you like, you can say let f of x equals to 3x minus 2. And then you differentiate f of x. F prime gives you, so the power is 1, so it's 1 times 3 is 3. You subtract 1 is 0, so it's just 3, and this goes to 0. So also you say g of x, which is the denominator, is x squared plus 7. So g prime of x now will just give us 2 times x, 2 times 1, the coefficient is 1, is just 2. You subtract 1 from 2 is 1. The derivative of a constant goes to 0. So you have f of x and g of x, let's say f of x, g of x, f prime of x, and g prime of x. So you can just put them now within the formula. We know that f prime of x gives us g of x times f prime of x, small f and capital F, minus. So even if you forgot the formula, you know that you have already differentiated f first. So you must hold f. That is, you just rewrite f function without differentiating it. And then you differentiate g function divided by g of x all square. So without thinking, you can just look at the function g of x. This is your g of x function. You just put it in. So g of x is x squared plus 7, x squared plus 7 times f prime of x is just 3 minus f of x is 3x minus 2. And then g prime of x is 2x divided by g of x. This is g of x, x squared minus s squared plus 7, s squared plus 7, and then g of x all squared. So you just square this expression. So that's it. Then you can simplify. The derivative portion now is over. So you just simplify. So it's 3 times, this is 3x squared plus 21 minus 6x squared, negative times negative is positive, 2 times 2 is 4x, divided by s squared plus 7 raised to the second power. So further, 3x squared minus 6x squared, it gives us minus 3x squared. The signs are different. We subtract the greatest number carry the sign, and then plus 4x plus 21 all over x squared plus 7 raised to the second power. If you want to factor out this negative, you can put it in the center of this line. Put it in the center of this line. And then when this is factored out, to not confuse you, put it in parentheses, right? So negative times this negative is positive, 3x squared. And then negative times positive is negative 4x. And negative times positive is negative 21. Divided by s squared plus 7 raised to the second power. So we've done with the first one. Now let's move to the next problem. So again, for this problem now, we're not going to go with the first method that we used. It's the same thing, but you may not have the time to be rewriting f of x and g of x. No, you don't have the time for that. So the function is y equals to x squared minus 3 divided by x plus 4. So y prime, or some books will say find dy by dx. That's the same as the y prime. So you say dy by dx is equals. Now what did the rule say? The rule say you square the denominator, but let's deal with the numerator first. The rule says hold the denominator, that is, we rewrite it, and then differentiate the numerator. So x squared, the derivative of x squared, we know that is 2x, and the derivative of minus 3 is 0. Minus, in the formula, we have a minus sign. Now, since you differentiated the numerator, now hold the numerator. Let's say we differentiated the numerator, right? So let's hold on to it, x squared minus 3. And we now differentiate the denominator. So the derivative of x is just equals to 1. Divided by this denominator, x plus 4, should be squared. That is it. We are done. So we simplify now. We get 2x times x is 2x squared plus 8x minus x squared plus 3 all over x plus 4 raised to the second power. So if we further simplify that expression, we have x squared minus x squared. That's a 2x squared minus x squared is just x squared, because it's like 2 minus 1, and then plus 8x plus 3 all over x plus 4 raised to the second power. So this is it. So let's move to the next problem quickly. So question 3 says y equals to x to the 5th power minus x plus 2 all over x to the 3rd plus 7. Again, we say y prime equals this denominator, we hold it. That is, we just rewrite it. And then we differentiate the numerator. So the derivative of x to the 5th power is just 5. We bring the 5 down, subtract 1 from this 5, level 4, minus the derivative of x is just 1, right? And derivative of 2 is 0. Minus, we hold the numerator now, x to the 5th power minus x plus 2. And then we differentiate the denominator. So we bring this 3 down, 3x, and subtract 1 from this 3, we're left with 2. The derivative of 7, which is a constant, is equal to 0. All divided by this denominator, x cubed plus 7, raised to the second power, according to the formula. So we simplify the numerator, right? So y prime equals x cubed times this expression. So we multiply this by this, and so forth. The fourth method. So x cubed times 5x to the 4th power is 5x to the 7th power. X cubed times minus 1 is minus x cubed. 7 times 5 is 35. X to the 4th. 7 times 1 is 7. 3x squared times 5 is minus 3x squared times x to the 5th power is just 3x to the 7th power. We multiply in leg of variables, we add their powers. 3x squared times x, negative times negative is positive. So this gives us 3x to the 3rd. And then 3x squared times 2, positive times negative is negative. This is 6x squared. Divided by, now don't expand this because it's already in a simplified form. So it's x cubed plus 7 all raised to the second power. So we collect like terms. 5x to the 7th power and 3x to the 7th power are like terms. So we can subtract 3 from 5, we get 2x to the 7th. Move to the next one, minus x cubed plus 3x to the 3rd power. So let's take the 4th power first. We have plus 35x to the 4th. And this gives us, this is minus, and this is positive. So it gives us plus 2 x cubed, and then we rewrite 6x to the second minus 7 all over x cubed plus 7 to the second power. So this is the third problem. Let's move to the fourth one. So the fourth problem says g of x is equal to 3x to the 7th, x to the 5th, 2x to the 4th, x minus 3, all over x to the 4th. Now, if we were not asked to use the quotient rule, we could use the power rule right here. That is, we can express each term over this denominator. So we can say 3x to the 7th power divided by x to the 4th power, x to the 5th divided by x to the 4th, 2x to the 4th divided by x to the 4th, x divided by x to the 4th, and minus 3 divided by x to the 4th. We would do it that way. But since we were asked to use the quotient rule, we must follow the instruction. So again, g prime of x, this indicates that we are about to differentiate. So this is equal. So we hold the denominator. The rule says the denominator, you should rewrite it without differentiating and differentiate the numerator. So what is it? 3x to the 7th power. 7 times 3 is 21. X, subtract 1 from the power, it becomes 6. This, the coefficient is 1. So it's 5 times 1 is 5. Subtract 1 from the power is 4. 2 times 4 is 8. Subtract 1 from the power is 3. And then this is 1. You bring this power down, it's just x to the 0 power, which will just give us 1. The derivative of a constant goes to 0. Minus. Now we have differentiated the numerator. Now let's rewrite the numerator. So it's 3x to the 7th plus x to the 5th minus 2x to the 4th plus x minus 3. Then we differentiate the denominator. So it's x to the 4th power. We bring the power down, which is 4, and we subtract 1 from the power, it gives us 3. All divided by this denominator, which is x to the 4th power, we must square it. Now, another easier way to simplify this thing so that we don't multiply this and also multiply this and this, since we notice that we have a common factor, x to the 4th, x to the 3rd, x to the 4th is a common factor, so we can bring x to the 4th outside. X to the 3rd, we bring x to the 3rd outside. So we'll be left with x right here, right? We'll just be left with x here. So we now multiply this x by everything in here. So we give us 21x to the 7th plus 5x to the 5th minus 8x to the 4th plus x. So let me put this back before we spoil the problem. Next error, we have already factored out this x to the 3rd. So the only thing we left with here is 4. So it's 4 times this one. So this gives us 12x to the 7th, 4 times this. Now this negative will affect everything in here. So 4 times x to the 5th is 4x to the 5th. Negative times negative is positive. 4 times 2 is 8. X to the 4th. This is minus 4x. This and this is positive. 3 times 4 is 12. Okay, let's put this in parentheses. All divided by x to the 4th raised to the 2nd power, power to power rule, we multiply. 2 times 4 is 8. Now this x to the 3rd power can cancel, and then we can take it from within this x to the 8. We left with x to the 5th. So we have g prime of x now. We just simplify. So it's 21x to the 7th minus 12x to the 7th. So we take 12 from within 21. So we'll be left with, okay, so let's take 10 from in this one first. You have 11, and you take 2 from there, you have 9. So we'll be left with 9x to the 7th. So we're done with this one. We'll go to the 5th power. 5x to the 5th minus 4. So it gives us just x to the 5th. And then we'll go to the 4th power. So this cancel this, right? Minus and plus. And minus 4 plus x gives us minus 3x. And then what else? The 12 is standing alone. So we have plus 12. All divided by x to the 5th power. So this is it. This is our answer. So let's do the last one quickly. The last problem is just very simple. So question 5 says f of x is equals to 1 over x. So we apply the same rule. We hold the denominator, which is x. We differentiate the numerator. The derivative of the numerator is just 0 because it's a constant. Minus, we hold the numerator and differentiate the denominator. What is it? The derivative of x is just 1. All divided by x raised to the power 2, because it said we should square the denominator. So this is just out. We just have f prime of x is just equals to minus 1 over x squared. So thanks all so much for watching, and see you in our next lesson. Thank you. Please subscribe to our YouTube channels, and also you can hit the notification button so that you receive all of our alerts when we upload new videos. Thank you.